Hello guys, I'm audible. Can you hear me? Hello. Hello guys, can you hear me? Hello, hello, hello. Please confirm it. Okay. So very good evening to all of you. So I'll be just be waiting for let's wait for another 4 to 5 minutes. Then I will start. Please inform in the group that the class has been started so that they can join. So guys, so we have basically started our discussion on the damped vibrations, and we have covered the portion like Coulomb damping and viscous damping. So these are the things, my dear friend, we have discussed. Now, not on the second thing, forced vibrations. Not on forced vibrations. Write down each and everything which is written on the slides. Now, till now, we have not talked about the vibration because of the force, the time varying force which is present all the time in the system. That force may be coming because of the unbalancing in the system, or maybe due to some other reason, but there is some force will be present. A system which is being excited by sinusoidal forcing function f naught sine omega t as shown in the figure. Right. In this system, you can see there is a spring, there is a damper, there is a mass, and it is being pulled in the x direction by the force f naught sine omega t. F naught sine omega t. Note down. Guys, here, if you want to draw the free body diagram of this mass, of course, at this static equilibrium, mg before applying the force, mg weight will be balanced by k delta static in the spring. Right? So mg force will be balanced by initial spring force, which is nothing but k into delta static. That is being balanced at the static equilibrium conditions. From the static equilibrium position, we are disturbing it further in the downward direction by the force F naught sine omega t. And let us talk about that. Let us talk about that thing, guys. You know down. So the complete free body diagram here you can see right on the equation of a motion. If you see, my dear friend, what is happening in this one, you observe very carefully, guys. There is a mass. Let me draw it. There is a mass, my dear friend, here. This mass, you can see there is a F naught sine omega t which is acting in the direction of a displacement. Mg force will be acting, which is balanced by this K delta static. This Mg will be balanced by this K delta static, which is I have written here. At the equilibrium, Mg will be equal to K delta static. Mg will be equal to K delta static. Mg will be equal to K delta static. Now, my dear friend, understand further after displacement, net force, what we can write, net force is equal to mx double dot. Net force is equal to mx double dot. Further, what we can write, guys? Further, what we can write, in the direction of a displacement or a motion, in the direction of a displacement and the motion, I'm writing my total net force is equal to mx double dot f naught sine omega t, which is acting in the direction of a displacement, minus of kx minus of cx dot is equal to mx double dot. So mx double dot plus cx dot plus kx equal to what, guys? F naught sine omega t. X double dot plus c by m, x dot plus k by m into x is equal to what? F naught by m into sine omega t. Further, my dear friend, again, the last equation, if you want to write, that is a good, well and good. Otherwise, you can ignore it. The most important equation here is that the equation number one. In the equation number one, what you are observing, guys, in this particular equation, earlier when we don't have any force, then we write down the equation as mx double dot plus cx dot plus kx equal to 0. And from here we got the omega d, we got each and everything, right? And we got the complementary functions. We got the complementary functions, something like that. But here, my different right hand side is not equal to 0. Right hand side is having f naught sine omega t, this term. Because of this term, my different, what is there? There is a particular integral will also be there. What is the particular integral solutions? So what is the total solution, guys? Complementary function, which already we have covered, plus particular integral. Particular integral. Let us talk about that. From where we are getting c by m, that is equal to 2 zeta omega, and I already written. Already you know this formulas from the viscous damping. Now, further note down. The equation number one is a linear, non-homogeneous second order differential equations, and the solution of this equation will consist of two parts. One is a complementary function, one is a particular integral. The complementary function already we know that, which is nothing but a2 e to the power minus zeta omega nt sine omega dt plus phi 2. Again, phi 2 is an initial phase lag and it is a constant which is depending on the initial conditions. What is the particular integral solutions? Xp is equal to what? X sine omega t minus phi, where x is what, guys? Amplitude, which is written in the form of what? Formulae. X is static divided by under root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square. Remember, omega by omega n is also called as frequency ratio. Omega by omega n is also called as frequency ratio. What is the x static? X static is known as f naught by k. F naught by k. What is the omega? Omega is nothing but forced frequency or excitation frequency. What is the phi? Phi is nothing but the phase angle. Phase angle. What is the 10 phi? See how these formulas we are getting. We will discuss further. No need to worry. Then guys, all of you have noted down. Note down further. What is the complete solution? This is the complete solution. Now, some of you might be thinking, sir, you have given the some different formula for the complementary function. No, I have not given different formula. If you write down the complementary functions, x divided by under root of 1 minus zeta square, x divided by 1 under root of 1 minus zeta square, e to the power minus zeta omega n t sine omega dt plus phi. There we got this formula by putting the boundary condition x dot is equal to 0 at time t equal to 0, and when time t equal to 0, x is equal to x naught. By using this, we got this one. This is a very general one, complementary function, which is valid for all, initial conditions. So what I have written, I have nothing. I have just replaced with this with the what constant a2. That's it. Everything remains same. Omega d, you know that what is the omega d? Under root of 1 minus zeta square into omega n. Please make a note of it. And particular integral, what is the particular integral? Particular integral is this was. Anything assigned with a sign that will become amplitude. This amplitude, unlike what we have seen, this amplitude is a function of time, which is decaying exponentially, but here it is not decaying exponentially. In fact, it is a constant. It is not depending on the time. So that's why it is called as steady state amplitude. Steady state amplitude. Note of the response. Whatever the response we got from the complementary functions, it is nothing but transient response because it is depending on the time. But a steady state response, which is not depending on the time, which is not depending on the time. If you plot total response, if you plug together, you will get this one. Xc plus particular integral both. Complementing function plus particular integral both. Done. Note of the next concept, magnification factor. Magnification factor. Magnification factor is basically it is a ratio of dynamic amplitude to the static deflections. We also call this thing as magnification factor. It is also called as amplitude ratio. We also call this thing as amplitude ratio. Understand what is the meaning of this thing. It's a very simple and very easy to understand. See guys, when my dear friend, when there is a when we apply the suppose in any system, if you apply force, which is a time varying force by using something like this. What is the maximum value of this force? This is the maximum value of this force. This is the maximum value of this force. If I apply this maximum value of the force and if I apply this force to the machine, machine is having some stiffness. If I divide F max by K, I will be getting some deflections. We will be thinking if I apply this much of maximum force, that could be the maximum deflection that can be possible in a machine, in a running machine. But once you got the amplitude because of the vibration by using the quantity called A, that is also called dynamic amplitude or a steady state response, the moment you got this particular value, you got surprised. You got to know that A is coming more than F naught by K. Then you say the value of F naught by K is magnified. That factor we are calling what? Magnification factor. Please make a note of it. Now here some of the tasks I have given here. It's a very simple thing. See, where you just apply the force F naught to the any spring, and if system is, for example, a static one, it is not rotating. That's why we are calling static deflections. When omega is zero, R will be zero. Put R is equal to zero into this particular formulas. You are going to get A that become A static. That is nothing but static deflection F naught by K. But whenever you have any system, the system is under running conditions. In that running condition, amplitude may be magnified. It may increase than this F naught by K. How much it is getting increased? That particular value is being magnified by using magnification factor. Right? Suppose F naught by K is the value, let's say 2 mm, and A is coming as, for example, 5 mm. Then what you will say? 5 by 2, that is nothing but 2.5 is the value by which it is being magnified. It is magnified by 2.5. It is being magnified by 2.5 factor, like that. You will come to know if you write down the A formula, steady state response, just now we got it. F naught by K under root of 1 minus R square whole square plus 2 zeta R whole square. My dear friend, if you just take this formula A divided by F naught by K, you are going to get amplitude, magnification factor formula, this one. From this particular formula, you will come to know that magnification factor is a function of omega by omega n and zeta. Again, what I'm calling R is nothing but omega by omega n, which is also called as frequency ratio. Frequency ratio. But for a particular system, zeta will be constant. So all I want to say that magnification factor is nothing but solely a function of what R. So what we can do, we can plot magnification factor versus R. Remember, magnification factor, it is also called as amplitude ratio. Somewhere you please note down. Note down this thing, guys. Magnification factor, magnification factor. You note of the formulas. If I want to get the maximum magnification factor, if I want to get the maximum magnification factor, then what I can do? I need to, we know that it is only a function of R. So what we can do, we can differentiate and we can differentiate this magnification factor with respect to R and equate to 0. From there, I will be getting some R that I'm calling what? R star, which is nothing but under root of 1 minus 2 zeta square, under root of 1 minus 2 zeta square. If at all magnification factor maximum value need to be exist, then 1 minus 2 zeta square has to be a positive number because we don't want that value to be complex number. So 2 zeta square should be less than 1. Zeta must be less than 1 upon root 2. Zeta must be less than what? 0.707. Zeta must be less than 0.707. So what all I want to say that magnification factor, the maximum value, if you put R star over here, if you put R star over here, then you are going to get maximum magnification factor, and it is only valid for zeta which is less than 0.707. That means if you say, in other words, if I am having the zeta more than 0.707, if I'm having zeta more than 0.707, maximum magnification factor will not be exist. It is one only. It is one only. It is one only. Put zeta 0.8. Put zeta 0.8, my dear friend, what you are going to get? Let's say if you put zeta is equal to 0.8. All of you have noted down 1.04, right? But that particular formula is not valid for this zeta is equal to 0.8 because it is only valid for zeta less than 0.707. 0.707. Why? Because you might be thinking, sir, 1.04, one something we are getting. You said 0.8, but you put 0.8 here. What is the R star? Tell me 1 minus 2. What you are getting, guys? 0.8 whole square into 2. Are you getting complex number or what? If R star is not being exist, see, for maximum magnification factor, we are getting R star. If R star itself is not exist, then what you are going to do? You are not going to see if that is not exist. How can you put into this formula and to apply this particular formula for 0.8? So it is only valid for 0.707, less than 0.707, and it is also valid for less than 0.707. So based on this, we can make some conclusions, very important conclusion. That means for a critically damped system, for zeta is equal to 1, there is a no maxima exist in magnification factor. So what is the maximum value that can be exist for a critical damping? 1. 1. For over damping, again no maxima. For under damping, when zeta is more than 0.707 and less than 1, again no maxima. But for under damp, when zeta is less than 0.707, definitely some maximum will be exist in magnification factor. What is the value of maximum? Maximum means more than 1. More than 1. Through the graph, it will be clear. Now, guys, please note down the graph, which is very, very important graph. The graph between the magnification factor and frequency ratio R, which is nothing but omega by omega n. See, my dear friend, you are having R is equal to, for example, 0. When R is equal to 0, at R is equal to 0, at R is equal to 0, you are going to get something like this. Magnification factor, when R is equal to 0, you are going to get magnification factor value is equal to 1. That is what we are getting, 1. But you can see for zeta, for the zeta, let's say, for example, zeta more than less than 0.707, less than 0.707, that means zero point 0.5, zero point 0.2, and for the 0, you are having some peaks. You can see that there is a peak. Let me pinpoint it. There is a peaks. What are all the peaks? What are all the peaks for zeta more than 0.707 or 0.707? Maximum value 1 only. After that, there is no maxima exist. And that is what practical meaning of mathematics. Second conclusion, when R is equal to 1. Whenever R is equal to 1, when omega just become equal to omega n, that condition will be called as resonance. That condition will be called as resonance. At the resonance, what is the magnification factor value? 1 upon 2 zeta. 1 upon 2 zeta. Put into this formula. Put into this formula. Which formula? This formula. Each and everything you will be getting. Third conclusion, when R is equal to 1 and zeta is equal to 0, there is an ideal case, under undamping case, no damping case, magnification factor value will be infinity. You see that. What is the value if the zeta is equal to 0, but R is not equal to 1? Then you are going to get plus minus 1 minus 1 upon 1 minus R square. R square. When zeta is equal to 0.707, put the value, formula. What is the formula, guys? We got the formula right. Yeah, this formula. For zeta 1 upon root 2, if you put into this formula, you are going to get 1. So maximum to maximum that can be exist is 1 only. For zeta is equal to 0.707 or more than that. Whatever the values will be there, it is nothing but 1. Maximum magnification factor will be 1. But for zeta less than 0.707, that means for this graph, for this graph, for this graph, what you are observing, there is a peaks, there is a peak, there is a peaks, which is more than 1. That's why it is being said that the maximum is exist in magnification factor. Please make a note of it. Once it is done, let me know. Note down quality factor. The magnification factor at the resonance is known as quality factor. Already we got the formula. See that? This formula. This particular formula. So when R is equal to 1, then whatever the value we are getting, that is nothing but quality factor. That can be called as quality factor. Just make a note of it. Note on the next particular concept, which is very, very important. Just now we got the forced vibration. Now forced vibration due to the excitation of the support. Let's say we are not applying any force, sinusoidal force or cosine force, but we are exciting the, suppose there is a, I know, basically there is a surface which is being excited by the value y is equal to y sine omega t. Because of that, each and every formula will remain same, like complementary function, particular integral, each and everything you are going to get, but there is some difference in the formulas. There we got the amplitude f naught by k by using this f naught by k divided by this one. But here we are going to get amplitude as capital X is equal to y under root of 1 plus 2 zeta r whole square divided by same value. Each and everything is same, only the difference will be formula will be getting changed. You will come to know soon x by y, which is equal to 1 plus 2 zeta r whole square 1 minus r square plus 2 zeta r whole square. From here, my different what you are going to get, x by y value. X by y value you will come to know that is nothing but called as motion transmissibility. Motion transmissibility. What is the meaning of transmissibility? You will come to know very soon. What is the capital Y? The base by which it is getting excited. Maximum value of the amplitude by which it is getting excited. Once it is excited, it will transfer its motion to the what? Machine. The machine will be excited by the amount x. Machine will be excited by the amount x, small x. If you write down the equation of a motion, mx double dot plus c. C is there in between x dot and y dot. K will be there in between what? X and y. So what we can write? X minus y. Don't write y minus x. You have to see always which is the first, which is the later one. So x minus y, like that. If you simplify it from here to here, you are going to get this. Again, there is a complementary function, there is a particular integral, and that is what I have written. Is it done, guys? Not only forced vibration because of the rotating and reciprocating unbalance. See, guys, whenever you say any machine, 100% each and every component is not a perfectly manufactured. There is a defect. When there is a defect, then their center of mass will be displaced by the amount E from the geometric center or center of rotations. And when the system is rotating, when this rotor will be start rotating by the quantity omega, then what will happen, guys? There is a centrifugal force will be produced, which is nothing but m naught E into omega square. That is called as maximum centrifugal force F naught. Let's say this force is making an angle with the horizontal theta, which is nothing but omega into t, because omega is what? Theta by t. So theta is what? Omega into t. What is the horizontal component? F naught cos omega t. What is the vertical component? F naught sin omega t. When the system is getting displaced by the amount x in the upward direction, which component will be responsible for the vibration? F naught sin omega t. My define each and everything is same. Again, you are going to get the amplitude formula exactly the same. But here F naught. Earlier, whatever the F naught we have written, we used to write, F is equal to F naught sin omega t. But what is the F naught? This is the F naught. I'm not E into omega square. It is not a very separate topic. It is a topic of a forced vibration. But I'm just showing you what is the how F naught is coming from, where it is coming, why it is coming. Right? M is nothing but total mass of the system, which includes the mass of the rotor. This is the mass of the rotor. What is the mass of the rotor? M naught. M naught. Please make a note of it. Why there is a forced vibration? This is the reality. When the machine is static, when it is not running, nothing called vibration will be there. Once the motion will be started taking place, everything problem will be started coming. And when this vibration will be too high, then fatigue life of any component will be very small. Life of the component will become very small. Then guys, please note down this particular slide, then I will explain. Again, if you write down the equation of a motion, Again, if you wrote down the equation of a motion, see at this moment you should not worry so much about the derivations. Each and every derivation is not at all important. Time is very less. But still, I'm explaining you so that you don't feel that yeah, everything is just in the air. The total system is having a mass of what? M, which includes the mass of the rotor M naught. Except the rotor, the mass is x, basically what displaced by the amount x. Except the rotor. That means I need to subtract M minus M naught. This much of system which is getting accelerated or maybe displaced by the amount what x? X double dot. M minus M naught, x double dot. Rotor is getting displaced by the amount what? This is the displacement. If you see in the figure, when the system is getting displaced by the amount x, then it is getting displaced by the amount what? This is nothing but E sine omega t. X plus E sine omega t. That much of displacement will be given for rotor. That's why it is like this. That is equal to minus kx minus cx dot. If you just rearrange the term, each and everything is same. Complementary function, particular integral. But here f naught is what? F naught is m naught into e omega square. F naught by k. We write f naught by k. What is f naught? This. See, there is no difference in the formula, guys. Don't worry. No difference in the formulas. Only f naught is what? M naught e omega square. Just it is being separately discussed. It doesn't mean that there is no connection between the forced vibration which we have started our discussion and this discussion. Both are exactly the same. Please make a note of it. Once you understand each and every derivations, then you don't feel any then you will not be having any fear about any topic. But the time is very less. If you start focusing on each and every derivation, by the end of the January, you will be in a position to finish only the derivation. With the help of derivation, you will not get more than 30 marks in GATE exam, 20 marks in the GATE exam. If you want to do that, then you can do that. Otherwise, it is not at all required. Unnecessarily, if you just want to make your GATE exam very bad, then you can do these things. There is a lot of fun in understanding the derivation, but there is no time. Time is money. Time is everything, right? Amplitude. So amplitude A divided by what? If you divide by m naught into E by m, you are going to get something these formulas. Something these formulas. Again, there is no minus. It's a plus. Now, how we are getting the phase angle? I will discuss. No need to worry. Then, guys, And guys, now we will solve some problem before moving on to the next topic. A mass, a spring mass dashpot, a spring mass dashpot system with the mass m is equal to 10 kg, spring constant, what the data has been given, mass is equal to 10 kg, K value is 6250 Newton per meter. It is getting excited by the F naught cos omega t. What is the force? F naught cos omega t, where F naught is what? 10 Newton. What is the excitation frequency? Excitation frequency will be 25 radian per second. If you compare this equation with the given, you know, equations. At this steady state, the amplitude vibration, that means A is given. A is what? Is steady state amplitude or dynamic amplitude, which is nothing but 40 mm, which can also be written as 40 divided by 1000, which is nothing but 0.04 meter. The damping coefficient of the dashpot will be how much? See guys, which formula need to be used? Amplitude, which is equal to A. They are asking damping coefficient. So we have the two formula, guys. Remember, we have the two formulas. One is F naught under root of K minus M omega square whole square plus C omega whole square. We can also have this formula F naught by K under root of 1 minus omega by see, both are same. I'm not saying both are different, but if you just write the one formula in terms of F naught K C omega M, well, this by looking at the data, this formula is mostly suitable here to be applied here. But sometimes they give frequency ratio zeta. This formula is applicable. How to get from here to here? Take K common from this particular under root. You are going to get exactly the same formula, right? So what I'm doing, I'm just removing this part. I'm writing only the formula, first formula, the first formula. What I'm writing here, F naught divided by A is what, guys? 0.04, which is equal to F naught. What is the F naught? 10 divided by K. What is the K value? 6250 M omega. What is the omega? 25 square. That is the whole square plus C omega whole square. If you do these calculations, this thing will be getting cancelled out because that is equal to 0 because 6250 minus 6250 equal to 0. So ultimately what you're going to get, guys, 10 divided by 0.04, which is equal to 25C. 25C. So ultimately 10 divided by 0.04 and divided by 25, C, you are going to get 10 Newton second per meter. Please make a note of it. We have discussed the Coulomb damping, but we have not discussed any problem related to that. Let us discuss about that. Let us discuss something about that also, some numerical about that. Can I move to the next one? Now try this with this question, guys. A single degrees of freedom spring mass system of natural frequency omega. They have given the natural frequency V, which is equal to 5 hertz. From here, how to get the natural frequency? 2 pi nu, which is equal to what? 2 pi into 5, 10 pi. Is this system is being modified in two manner. Case number A, case number one, viscous damping with the damping ratio 0.2 is introduced in parallel to the spring. Whenever we introduce any damper, the natural frequency will become omega d. And what is the relation? This is the relation. What is the case 2, guys? Case 2, they are saying the original undamped system is being moved on a surface with the coefficient of friction 0.01. Whenever there is a Coulomb damping, I told you the natural frequency will remain same. The damped natural frequency will be what? Omega n only, right? So might even if you just take the ratio of damped natural frequency for a case number one to the damped natural frequency for a case number two will be what, guys? 1 minus zeta square into omega n divided by omega n. You are going to get under root of 1 minus zeta square. You are going to get what, guys? 1 minus zeta. What is the zeta? Zeta value is what, guys? 0.2. So that is what the final answer, guys. Please make a note of it. You are going to get 0.979. Case 2 I discussed, see, let me take you back to the case 2. Case 2, if you just see the previous slide, the previous lecture, in the previous lecture when we started our discussion in the Coulomb damping, how the system is responding, guys. What is the total solution? A cos omega n t plus B sin omega d. Anywhere you are observing omega d, still there is a friction, Coulomb friction, but still the system is vibrating with about omega n. So can I say the damped natural frequency is still the values of omega n? But in case of viscous damping, it is replaced by what? It is being replaced by omega d, which is equal to under root of 1 minus zeta square into omega n. Are you getting my point? So that's why I have written here omega d for the case number 2 will be still remains same, omega n. Can I move to the next concept? Please note down vibration isolations and transmissibility. Vibration isolations and transmissibility. What is the meaning of vibration isolation? Generally, guys, if I directly place the machine, suppose if there is a no spring and there is a no damper, if I directly placed this machine on a surface, ground surface, there is a other building also there, other building also there. When the system is start vibrating, for example, the system is start vibrating, the ground, this whatever the vibration will be there, this vibration will be transmitted to the ground also. And on the ground, you know that in on the earth, there is a your machine will not be placed. On the earth, there are so many human beings, so many buildings are there. If the ground is start vibrating, nearby building will be start getting vibrated. If it is start getting vibrations, what will happen, guys? The building may collapse. The machine, nearby machine may collapse. To avoid that, what we do, we place the isolators. What are all the example of the isolators? Rubber, cork, metallic springs. Right? Hold on. So now some of you might be thinking, sir, how this is functioning, how it is reducing the vibration to be transmitted from the machine to the ground? Yes. See, machine is basing generated by how much force? F naught. That much of force is being applied to the machine. But how much of actual force getting transmitted to the ground? Only Ft. Out of F naught, only some portion is going to the ground in the form of Ft. Now some of you might be asking, sir, what is Ft? Ft is nothing but the resultant of spring force, the damping force. Because there is a spring and there is a damper. So these two only will transmit the force. These two only will transmit the force. Now we are very much interested to know how much of force which is getting transmitted to the ground and how much of actual force which is applied to the machine. This ratio will be called as transmissibility or T. For a for a good isolation, this value should be less than 1. So whatever the force which has to be transmitted to the ground, that should be very, very less than F naught. Not on the transmissibility, not on each and everything, then I will discuss. Transmissibility, guys, understand we denoted by epsilon. Epsilon is basically it is a ratio of Ft divided by F naught. Now, what is the meaning of Ft is nothing but the force which is being transmitted to the foundation or a ground. F naught is nothing but the maximum disturbing force. Maximum disturbing force. What is the max? See, I told you that force which is getting transmitted to the foundation will be from the spring and the damper. What is the maximum spring force? K into X. But what is the XA? What is the damping force? C into omega into A. How we are getting these formulas? I will discuss separately. No need to worry. Right? Please make a note of it. Now, some of you might be thinking, sir, when there is a two force, F1 and F2, make an angle, for example, phi. If I found out the resultant force, I should be getting this formula, F1 square plus F2 square plus 2 F1 F2 cos phi. But you are writing this formula, sir, how? Cos phi, the phi value is what? Between the spring force and the damper force, the angle is what? 90 degree. When 90 degrees, what? This value will be 0. So F1 is what? Spring force. F2 is what? Damping force. That is what it is being written. So if you take A common, then A divided by F naught, you already know that this particular value is there, this particular formula. And if you just write down, don't write this value, don't write this thing, not required. You know not to hear. Transmissibility formulas. We can also write, see, this is the one formula. This is the one formula which we have written in the form of C omega K M, something like that. But you can also write the formula, transmissibility formulas, in the form of frequency ratio, omega by omega m. How? You can take common from numerator and denominator, then that will be C omega by K whole square plus 1 square divided by, if you take K common, 1 minus m omega square by K square plus C omega by K square. Then you can write down some formula, interchange it. Then you can write in the form of what? Omega by omega n. Right? Let's see whether there is a form. Yeah, it's there in the slide. I will discuss. Done, guys. No down. I told you right. There is a one more formula in the form of zeta and r. This is the formula. And how we are arriving these formulas? Each and every step I have written here. C omega by K, that can be written as 2 zeta into R. If you take K common, if you take common, and if we write down A divided by F naught, A divided by F naught, if you write down A divided by F naught, then you can write this particular formulas where omega by omega n is what? R. I'm just telling you the shortest possible derivation so that you don't get confused. If you forget the formula, still you can derive in the examination hall. Why? Because it is very necessary to remember all the formulas. In GATE exam, there is no time to derive there. If you are start deriving, you are out of the competition there itself, right? It's a very, 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 basically super fast exam. 3 hours, only 3 hours. That's it. Each and every formula should be on the tip of your hands. You should have enough practice before going for a GATE exam, right? Until the last moment, you will feel that I have not revised properly. I'm forgetting. This thing will be keep on happening, but still you have to be just, basically move forward, and then you have to write the GATE exam. After this much of a struggle, definitely something fruitful will be there from the GATE exam. No need to worry. It happened with everyone. Now, coming back to the discussion, transmissibility by looking at the formula, these formulas, it is basically a function of R. Why? You might be thinking, sir, R is there, Z is also there. But why you are saying only R? See, it is a function of a system. Once the system is decided, you cannot change zeta. You cannot change zeta. Second thing is that until unless you are modifying stiffness of the spring and something you are modifying damper, you cannot change zeta. So transmissibility is a purely a function of R. What is the R? Omega by omega m. Okay. Once I put R is equal to 0, I will be getting transmissibility is equal to 1. That's a very obvious thing. Once I will be putting R is equal to root 2, again I will be getting transmissibility equal to 1. How many times we are getting transmissibility is equal to 1? 2 times. One is omega by omega n is equal to 0. Second is omega by omega n is equal to root 2. Make a note of it. Now we can plot transmissibility versus R. Now we can plot transmissibility versus R. Please make a note of it. This particular graph, then I will explain. Transmissibility versus R. I told you there is a two time when the transmissibility will become 1. One is basically at R is equal to 0, when R is equal to root 2. And when R is equal to 1, obviously transmissibility will be equal to infinity. Infinity. But look at in the graph very carefully, my dear friend, what you are observing. When zeta, when we are working in this zone, is in between 0 and root 2, when R is in between 0 and root 2, what you're understanding is that effectiveness, whatever the transmissibility is there, that always more than 1. When you take zeta, when you try to see the zeta, when the transmissibility is keep on increasing, the value of zeta is keep on decreasing. That means still this zone is not at all very useful for us because transmissibility is more than 1. There's no doubt about it. But whether we are having the transmissibility, maximum transmissibility less for higher value of zeta or lower value of zeta. If we look at in the graphs, we have the highest transmissibility. For example, forget about infinity. We are having the highest transmissibility for lowest value of zeta. For example, zero point 0.4. For example, zero point 0.4. So zero point 0.4 and 0.6, 0.4 is having high transmissibility. That means what is happening, guys? Zeta if I increase, transmissibility will decrease. Zeta if I increase, transmissibility will increase. Now tell me, guys, watch which thing you will require. Should I increase my zeta? If you are working in the zone of in between 0 and 2, should I increase my zeta? Just look at this particular graph and tell me. See, I am having two statements. One statement, if I am working in between 0 and root 2, I have marked here in this root. In this particular zone, I am having two values. One is a zero point 0.4 and one is a zero point 0.6. For which value you are having highest transmissibility for the red color. That means if you are having low damping ratio, damping when you are having low damping ratio or damping factor, then you are having more transmissibility. If you are having more damping ratio, less transmissibility. So if you suppose you got to know that we have to work in this zone, definitely you have to increase zeta. Definitely you have to increase zeta. Definitely you have to increase zeta. That's why it is called as damping control zone. Damper is not at all creating a problem. Of course, this zone is a worst zone because transmissibility is more than 1. Coming back to this zone, in this zone, when I increase my zeta, like this, when I increase my zeta from 0 to 0.4 to 0.6, the transmissibilities keep on increasing, keep on increasing. When the transmissibilities keep on increasing, that is not desirable. But this zone is a very good zone because in this zone, transmissibility is what? Less than 1. That's why we said if transmissibility is less than 1, that is said to be what? Effective isolation. Effective isolations. That means what we can understand, one more thing, when R is more than root 2, when zeta will be more, transmissibility will be more, damper is creating a problem. If damper is creating a problem, that's why this zone is called as spring control zone. In this zone, transmissibility is less than 1. That's why it is also called as isolation zone. Please make a note of it. Very simple graph. Try to manipulate, try to see what you can get the information from this graph. And that is what you have to see in the GATE examination, what question they are asking. Presence of mind should be there in GATE exam. That's it. No question is tough, no question is easy. It all depends on your presence of minds. If you are going in the GATE exam without remembering the formulas, you may be thinking, sir, each and every formula I will derive in GATE exam. Again, I'm telling you, don't do this blunder. Write multiple time each and every formula on a blank sheet. Take a blank sheet, write down each and every formula. Suppose, for example, subject number 1, fluid mechanics. Write down each and every formulas. First, you revise it for the next 30 minutes. After 30 minutes, close the book and write down each and everything. Try to verify whether you are writing without seeing whatever you have written that is matching or not. You can check it and you can verify how much you are capable to remember it. You do it multiple times on a regular basis. For example, you have the class of 6 hours. After 6 hours, basically don't take the rest. See, 10 to 6, you should have a proper sleep. For example, you have for example, you have the class till 11. The moment classes gets over, you have to sleep. There is no option. So, for example, 11 p.m. is there to 6 a.m. or maybe 5 a.m. In between, you have to sleep. Suppose some of you might be having habit of studying in the night. Of course, don't change it at this moment. If you are having, continue it. But suppose if you are basically a regular student who is sleeping in between 11 p.m. and 6 p.m. 5 a.m., definitely you are going to get the fruitful results. Why? Because this is a sleeping time, right? After this one, my defend, wake up early in the morning, 5 a.m., do fresh up and all, get ready by 6 a.m. After 6 a.m., guys, take a paper, blank paper, note down each and every formula's concept. Whatever you can remember, note down each and everything. Previous day, whatever you have studied, note down each and everything on that blank sheet. Take one mock exam, subject wise or topic wise, and just write it and analyze it. How much you are getting, how much you are capable to remember the formula, whether you are doing calculation mistake, conceptual mistake. These are the part of the basically what your preparation for GATE exam. Don't think that, sir, if my syllabus will be completed, that day will be happiest day. That will be the final day. After which I will be writing mock exam. I will be start doing practicing. That day will never come. You have to find the time. You have to find the time. Again, I'm telling you, you have to find the time, right? So definitely, if you decided about your future that I will be taking crash course, so some of you definitely you might be having in your back of your mind that okay, something I have covered. I need only the crash course for completing this particular no gate particular course, and then I will be writing the gate exam. So already you have taken the risk of selecting the crash course, right? Because you have not selected the full regular batches. Again, there's no problem in that. Why? Because they are having some different purpose. You are having some different purpose. You might be having basic understanding very strong as compared to those batches. That's why you have taken this particular course. Or maybe you are having, maybe you have decided to start the gate preparation lately, and that's why you have joined. Whatever the reason may be there. But in gate examination, whatever the question paper will be given to you, they will not be asking you whether you are from crash course, whether you are from the regular. They will be giving you same question paper to both of you. So you have to fight. You have to fight with the good students. Are you getting my point? What I'm saying? Tell me, guys. Yes or no, guys? All of you understanding what I'm discussing right now? See, because this thing will not be discussed, most of the time during the classes, but these things are very, very important for gate examinations. Gate examination is not a very joke exam, which you can just one day you wake up in the morning, sir, I have decided to write the gate exam. I have started my preparation and I'm going to write the gate exam. They will throw you like anything in the gate exam. Maybe you may not be able to get the 1 marks also. They will be testing aptitude. It is not a university exam. It is not a UPSC exam, which testing your how much knowledge you have, how much you are able to remember each and everything, like a robot. They need the smart robot, which can apply the aptitude also. Right? Some of you, if you have written the GATE exam, they are aware of that, how cruel this exam is. But if not, then you can just have a taste of it. But all I want to say, before basically surrendering, try to maximize your potential. Don't surrender, early only. Some of you might be thinking, sir, too much syllabus is there. I have done the blunder. I have selected the crash course. There's no time. See, there is a lot of things to think about that. You have to see only positive side of that. That's it. You cannot go back from now. You cannot go back because this class is there only for not for you guys. Some of you they will be start listening the recording also. So those guys also they will be listening and they will be understanding what I'm talking about. Those who are regular attending the classes, there is no problem at all. Those who are practicing the problem, there is no problem at all. Those who are sincere, there is no problem at all. But after gate results, nobody will be asking you whether you are too much good student, whether you have attended the class regularly. They will be asking you the result. Where is the result? Where is the marks? Which batch you have selected? from where you are coming, which corner of the India you are coming, whether you are basically IITian, non-IITian, they will not be asking. They will be asking, what is your gate result? That's it. You tell me the result. In India, we are living in a society which they are asking about what? Final results. That's it. Once you have final results, no matter you are IITian or not, they will be start respecting you like badly. Again, I'm telling you, the results of GATE examination matters a lot in your career because whole future will be decided on your GATE examination, the 3-hour movie which is going to run in the month of February. That's why there is a difference between UPSC exam and GATE exam. UPSC will give some chances. Prelims, suppose you have lacked in the prelims, they will give you some chance in the mains exam. In GATE exam, it's a suicide. Either you go in or go out. That's it. Why I'm using this harsh word, because some of you might not be practicing enough. They might be thinking, sir, whatever I'm practicing, that is so much enough. That is enough to get the good rank. But that is not. Even I have not seen your preparation at the zero level, but I can say that whatever the preparation you are doing, that is not enough. You have to improve a lot. You have to practice a lot. Daily, 50 question you have to solve it, combining all the subjects. How you are finding the time, from where you are finding the time, it's up to you, right? But try to get the good rank in the GATE examination, because if you are going to get the good rank in GATE exam, based on that, MTech will be decided. Based on that, your college placement will be there after MTech, right? After getting placement, whether you are having a package of 6 LPA, 10 LPA, 12 LPA, 15 LPA, all matters a lot, guys. Because after that, when you switch the company, from one company to another company, they will be seeing you starting salary. Based on that, they will be start giving you hike. So some person who is starting their career with the 10 LPA, one person is starting with the career 6 LPA. I'm not saying that the person who is started their career with a 6 LPA, that is a full person. No, that is a good only. Some earning should be there. But whatever the opportunity this person will get, that person may struggle at least 5 to 6 years to get that, position of a person who got 10 LPA and in the starting. All these dramas are happening because of what? Gate rank. IIC Bangalore, good package. IIT Bombay, again, lesser than IIC Bangalore. IIT Madras, lesser than IIT Bombay. All these things are there. Just 3 hours will decide your next, all I can say, the remaining 30 years of your life. Maybe 40 years, you can say, considering the 60 to 65 retirement age. Right. So again, don't take GATE exam lightly. Again, I'm saying you cannot afford to take this exam lightly. Never. Even a single minute, you cannot waste it. Please make a note of it. Even you are wasting 1 minute of your time right now, you please stop it. Please stop it. You have to be very selfish. Don't think about your father, mother. Everything will be taken care. It cannot be done. Basically, nothing can be done in 1 month, right? Everything can be wait for 1 month. If they need some help from you, you can say that. Just wait for the 1 month or 1.5 months. That's it. That's why I use the word. You have to be selfish. You have to think about yourself. That's it, right? Just devote yourself for the next 40 days like anything, right? After that, whatever the results will be there, that is your result only. If you are getting good marks in GATE examinations, the next the problem is that if you are getting the low marks in the GATE exam in India, this GATE examination is conducted only once in a particular 1 year, right? After Feb month, you have to wait for again Feb month. This waiting time is not easy to digest. After getting passed out, this particular 1 year waiting time is not at all easy, guys. Believe me. So try to get the rank this year itself, whatever the rank which is possible. Put your effort, maximum potential, whatever you have, you try to show it right now only. Now, guys, coming back to the topic of vibrations, I will discuss from where we are getting, no need to worry. Tan phi, the phase angle, I have written one more formula. If I just go back and show you, one more formula we have written. If you just see here, the formula which we have written, this one. This is the formula we have written. Exactly the same formula we can also write in some another format. That particular format I have shown here. That particular format I have shown here. In the form of C omega Km. Now coming back to the next thing, if we write down the value, for example, particular integral. What is the particular integral, guys? The particular integral we have x is equal to a sine omega t minus 5. What is the x dot? X dot will be a omega cos omega t minus 5, which can also be written as a omega sine omega t minus 5 plus pi by 2. Again, what we can write, x double dot minus a omega square sine omega t minus 5. From here, by default, what is the maximum acceleration? Whatever it is being assigned with the sign, that will become maximum value. But here we have written acceleration. That's why we are writing maximum acceleration, which is nothing but a omega square. If you write down the equation of a motion, f naught sine omega t minus mx double dot minus cx dot minus kx equal to 0, right? F naught sine omega t. What is the x double dot? Note down from here. What is the x dot? Note down from here. What is the x? Note down from here. You please complete it, then I will discuss further. I told you, right, I will be discussing how we are getting the maximum damping force, maximum spring force. There you can see. Whatever the coefficient of sine and cosine, that will become maximum value or amplitude value. F naught is what? Maximum unbalanced force. Ma omega square is what? Inertia force. Damping force is what? C A omega. Spring force is what? K into A. These are the maximum value. This is the equation of a motion. From here, we are taking F naught sine omega t minus this quantity I have taken this side. And that I have equated to 0. Once it is done, we can plot the graph. Just take care of the sign, angle which is being assigned. Based on that, we can plot the rotating vector diagram. Can I move to the next one? Please note down the rotating vector diagram. The first plot we have plotted, if you see the formula, f naught sine omega t, f naught sine omega t. That means with respect to horizontal, this angle is what? Omega t, f naught. If you see the second term, omega t, but there is an angle difference of phi. Previous slide, yeah. Then is it done? M a omega square sine omega t, but it is making an angle omega t minus phi. That means this angle is phi. That is the inertia force, maximum inertia force. If you see the term C a omega minus C a omega sine pi by 2 plus omega t minus phi. This can also be written as plus C omega sine pi plus pi by 2 plus omega t minus phi. That means omega t minus phi, I need to move angle by what? 90 degree, again 180 degree. Then I will be getting damping force. And if you see this Ka sine omega t minus phi, so we can also write plus Ka sine pi plus 180 minus phi, omega t minus phi. That means whatever the omega t minus phi is there, I need to rotate 180 degree. I will be getting spring force. So at all the time you will be getting spring force and the damping force. They are having the angle what? 90 degree. That's why in the resultant force we have found it out F1 square plus F2 square under root of that. Please make a note of it. This is called a rotating vector diagram. If you just take the just write we write on the vector, same way if you write on the force, you will get the force polygon if you combine all the forces. That is what we will do in our next slide. Is it done, guys? All of you have noted down? Note on the force polygon. Everybody know F naught is there, then K is there, then C omega A. Just note down each and everything as the direction wise. And phi is nothing but the phase angle between the displacement and the F naught. From there, I told you I will be finding this phase angle. Phase angle is nothing but tan phi. What is the tan phi? C A omega divided by K minus M A omega square. Because what is this value? K minus M A omega square. C omega by K minus M omega. Now some of you might be thinking, sir, how we are getting the second formula? Very simple. Take K common. C omega by K, 1 minus M omega by K, M omega square by K. And use the formula what we have written. C omega K, that can be written as what? 2 zeta R. So you are going to get the exactly that particular formula. Note on one question. Find the phase angle at the resonance. Resonance means when omega is equal to omega n. We can also write omega by omega n is equal to what? 1. When you substitute omega, whenever we have omega, you write down omega n, you are going to get infinity. Tan phi is infinity means what? Phi will be 90 degree. Remember omega n. What is the omega n? Under root of k by m. So what is the omega n square? It's a k by m. Once it is done, we can discuss some problem based on this. Done, guys? All of you have noted down? Try to solve this question. In a vibration isolation, which of the following statement is not correct regarding the transmissibility? Every graph need to pass through these 2 points. And this value is infinity. Positive is equal to 0. rough diagram I have plotted here. T is nearly unity at a small excitation frequency. That means when omega by omega n is very, very low, this value, obviously omega is equal to what? T is equal to what? 1. Correct statement. T can be always be reduced by using the higher damping at any excitation frequency. See, in this direction, zeta is increasing, transmissibility is increasing. That means what they're saying, T can always be reduced by using the higher damping. If you use higher and higher damping, 0, 0.2, 0.4, the transmissibilities keep on increasing. The transmissibilities keep on increasing. So it is not correct. This is the right statement. This is the correct answer for this question. But let's see other option. T is unity at frequency ratio root 2, yes. T is infinity at the resonance, yes, for underdamped system. So B option is incorrect. Because if you're working in between up to root 2 only, when up to R is equal to root 2 or less than root 2, what you are having, guys? Zeta is increasing, then only transmissibility epsilon or T is decreasing. You see that? When zeta is increasing, what you're having, guys? When zeta is increasing, because in this direction, zeta is increasing, then definitely always transmissibility will decrease. But whenever you are working in this zone, it is not true. They have to specify the zone, whether it is less than root 2 or more than root 2, but they have not specified. They are generalizing the statement. That is not correct. So this is the gate exam. They don't want whether you are remembering the graph or not. You remember the graph, but you should be intelligent enough to be answer any question which is being asked on the that particular graph. That's a difference, guys. That's a difference. First option is right, but that is statement is correct, but they are asking not correctly regarding the transmissibility. Is nearly unity, right? See that? At a small frequency ratio, when omega is less than omega n, that means R is very, very less than 1 up to here in this zone. Try to see this question. The more question I will add for a homework. Once I will, no, most probably I will upload the notes tomorrow morning. In a single degrees of freedom for a underdamped system of a spring mass damper, additional damper on this system, additional damper is being placed in a parallel. Unlike just like what we have seen in the spring, here also my different whenever we add any damper in the parallel, what is the C equivalent? C1 plus C2. But whenever we have anything to the series combination, this is the parallel. Whenever we add anything to the series, just like the spring, they are also behaving in the same manner. That means if I add the spring, add the damper in a parallel, C will increase. When C will increase from the formula 2 zeta omega n is equal to C by m, when C will increase, zeta will increase. What about the formula for the time period? 2 pi by omega d. 2 pi by 0 minus zeta square into omega n. My dear friend, omega d can also be written as 1 minus zeta square into omega n. When zeta will be increasing, this quantity will decrease. This quantity will decrease, this quantity will always decrease. C is correct. What about the A and B? Transmissibility, when you write the formula in the form of zeta, 2 zeta r whole square See, zeta is there in the numerator also, in the denominator also. So we cannot decide whether transmissibility will increase or decrease, right? So definitely A and B is not correct. Always, this always word is very, very important in GATE exam. But the time period will always increase because omega d will decrease. Right? So that's all about the vibration, guys. Remaining question I will add as a homework. You have to practice. You have to practice a lot. Right? Just make a note of it. Once it is done, we can leave for the day and wish you best of luck for the GATE exam. Single degrees of freedom is finished. 2 degrees of freedom will be taken by Dinesh sir. Maybe he will be starting from tomorrow. Maybe next week onwards he will be starting. Done, guys. Okay, guys, thank you. I will upload the all the lectures and some assignment uh, tomorrow morning by tomorrow morning. Thank you all.